So this is about rational functions, and basically we have our test coming up right before break. We have about a full week next week, a couple of days this week, and a couple of days that next week. So it's about a 2-week unit, a little less. All right, so what the heck is a rational and how do you graph them? I need to get you a few essential vocabulary words, like what the heck is a rational function. You'll have to know what asymptotes are. There's horizontal, vertical, and slant asymptotes, but it does say we will not discuss in this class, and that's true. They're complicated, the slanted asymptotes, but the asymptotes that just go horizontal and vertical we're going to talk about. You have to know what a hole is, and you have to know what intercepts are. So off to the side, everybody draw this, and y equals 1 over x. You were taught this parent function, but it's been a long time. It's the one that has asymptotes in it. Rack your brain for it like it's an ACT question, and you had to know which, it'd be multiple choice then, but you'd have to know which of those, 5 sketches it was. What does this look like again? All right, you either know by now or you don't. It's this one where there's a curvy line here and another one here. Glad you're here, but that's really distracting. Please be on time. All right, so that's the sketch of 1 over x. That is called a rational function, and the reason, the word rational, you're supposed to know. A rational number can be written as a fraction. That's what rational numbers are. Rationals can be written as a fraction. Things that are not rational can't be written as a fraction. Like this is called irrational. There's no way to write square root of 2 as a fraction because it's a decimal that goes on forever and never repeats. All right, find the notes. So rationals can be written as fractions. So since this whole unit is called rationals, you should know what a rational means. And a rational number can be written as a fraction. Like this. That's written as a fraction. All right. So this graph right here has asymptotes. And this is called a horizontal. And asymptotes are special. Glad you're here, but you are late. Please be on time. Horizontal asymptotes are written that way, and vertical asymptotes are written that way. Horizontal asymptotes, vertical asymptotes. All right, take notes on this right here. I'm going to pause for a second while we can let the people that just got here catch up. Okay, so this is a rational function, and this is the new unit, and a typical question in this new unit has problems like this, and I just want you to get the big picture here for a second. And we need to look at something like that and go, what would that graph look like? Whoa, that's much more complicated than what we were just doing. We were just doing things like this. So you have to know factoring, because if you can factor it, you should. And when you do factor things like that, you'll have to know how to cancel stuff. And when you do cancel stuff, you got to know what that means. All right, so that's kind of where we're headed in the big picture with rational functions. But first, we just got to get down a few things like horizontal asymptotes go like the horizon. I'm going to do it again with a green dotted line just so you can see. That's the horizontal one. And those are it's really easy to get confused on this. Horizontal is either an x equals number or it's a y equals number, and it's so easy to get them messed up. So I have a way to remember it. It's the horizontal asymptote. And the vertical asymptote, that's the zertical asymptote. So the verticals are x equals things, and the horizontals are y equals things. Because I even get confused. Because like that green dotted line I just did, that's the x-axis. So doesn't it feel like it should be x equals 0? It does to me, but it's not. It's y equals 0. So the horizontal asymptote is at y equals 0. It's all the spots where y is 0. Like this is a spot where y is 0, and this is a spot, and this is a spot. All of these are spots where y equals 0. So that's why it's the line y equals 0. So vertical asymptotes, are they x equals 1s? All right. So first I should probably just say, what if we had a simple little move? We had 1 over x plus 2. Well, then it would take my graph that I just had, and it would move it. Which way would it move it? It would move it to the right or to the left. That's your choice. What's your gut? Somebody take your best guess. Do you think this moves left or right?
Left.
Left is correct. Nice job. Now let me give you a reason like how it's like something you remember from the past. Do you guys remember parabolas like y equals x squared? But if we did this, do you remember that would move like right 4? Does that ring a bell? That would move right 4. If I put a plus, it would go left 4, right? So if the change is in here, then it was a horizontal on the inside kind of a change. Do you get this is on the inside? And so that's kind of a horizontal change. So horizontal means like left and right, because remember horizontal is like this. Okay, so that thing moves left 2. So then I take my original graph, which would have been here, and I move it all over left 2. So now I'm going to rewrite it like that red line. I just moved the black line to the left 2. Same thing with this. I moved it to the left 2. Now I'm going to put in green asymptotes here and here. And my final answer for this would be the red lines over there. It's like the black one was the original one, but it got moved left 2. So now I'm going to erase out the black lines because it's maybe a little too messy. And do you get that my asymptotes and everything moved to the left 2 spots? Are you getting that? I'm getting so little response from you guys. I know it's morning. Ryan, are you on your cell phone? Put it up in phone jail. No, you're not? Okay, good. You're just looking down funny, made me think you were. Okay. All right. So, next up, I'm going to go, what does this mean? Hint, it's not left 4 because it's on the outside. Horizontal stuff goes on the inside. What goes on the outside? It's vertical. So that's a vertical move. That would move the whole graph where? Up 4. Good. All right, then write this example in your notes. Y equals 1 over x minus 3 plus 7. You should be able to say that this takes the parent graph and moves it which way and which way. Don't say it, write it. Which way did my rational function get moved? Right 3, up 7. How many of you knew that? Raise your hand if you did. Okay, good. Now, I think if I just said sketch it, I think you'd all be able to do it, but it's not going to be like super easy. Take a best guess of where this thing should be and sketch it. Remember, it starts like this. So you don't have to write the original, or it actually be really smart to write the original and then drag it. You guys have the capability on your software. I really wish mine did. Mine doesn't let me grab and drag things. Like, I got a little hand thingy here, but it drags the whole thing. It won't drag like just part of it. So I think you could drag just the blue thing over, or just the blue thing separately. You could drag them over. I can't explain everything if you're listening to me. This is the company I use for the recordings. You need to get a way to do that. It would be so handy. All right, so I'm going to drag it all to the right 3. So I have to do it in like separate little chunks. So that's me moving it all to the right 3. And then I'm going to move it up 7. So take this and move it up 7. And then take this one and move it up 7. And the asymptotes go here. That's the horizontal one, like the horizon line. And there. The vertical asymptote. Now, do you remember me saying that the horizontal asymptote was the horizontal asymptote? Figure out what it is. It's y equals something. And the vertical asymptote, hopefully you know what vertical leap means, like up and down. And the vertical asymptote is the zertical asymptote. So what are they? All right, I don't want to put for any particular kid, but I want participation. So I will get Dice of Destiny to do the asking. If you struggle, I will walk you through it. But there's no sense in just saying, I don't know. Because I'm going to stay with you. So try your best. Horizontal asymptote is a y equals thing. Vertical is an x equals thing. Row 1, person 1. That's rare. Today, Sophia, that's you. What's the horizontal one? And that's how much we moved up, and you are correct. We moved up 7, so it's y equals 7. Good. Row 1, person 4, Bontheus, that's you. Vertical asymptote.
3.
Yes, because we went to the right 3, and that's how far over we moved, and so, yeah, there we go. Okay, now if I had only one tip for you on this test. Like, I saw our test and I thought to myself, if the kids can just do this one thing, they could probably do really well on this test. And you know what that one thing is? It's your best friend in graphing. For every graph you ever do, you can make a list of points. And if you make enough dots that are on the graph, you'll know where the graph is. Like, if I didn't know where these lines were, but I knew there was a dot here, a dot here, a dot here, a dot here, you'd be like, oh, I guess it's where that blue line is. You know what I mean? If you have enough dots. So same thing with this one. If you knew there was a dot here and a dot here and a dot here and a dot here, you could connect the dots. Heck, a small child can connect dots. So what are some points? Everybody, please put in 3 and a weird thing will happen. Put 3 into this equation, and a weird thing happens. Do you get 1 over 0? Does that even exist? No, so that's what makes the asymptote. The reason we put a dotted line on the graph for the asymptote is because that's a place where the graph doesn't exist. You don't have an answer for it. You can't put a dot. So that's a really important spot to find. And remember, x equaled 3 was the vertical asymptote. Is it coming together? Does that make sense? Okay, so you start with that, and then you go on either side of 3. Like, obviously, what's on the bigger side of 3? 4. So try 4. And then what's on the smaller side of 3? 2 is. You don't have to put these in order, so I'm just gonna do 3 was my logical starting place because it found the asymptote. Then put in something on either side of that. So everybody stick in 4, and yes, the answer has a fraction. Oh, but it simplifies and it's not that bad. All right. Clara, what do you say for putting in a 4 into this equation here? Where does it go? Yep. And it simplifies down to 1 over, you can do it, 4 minus 3. Good. And then you add 7. What's the final answer? 8 is correct. 4 comma 8. Mr. K, Mr. Keatley, can you tell me if I put in a 2, walk me through it here, 2 minus 3 makes? So it's 1 over negative 1, which is, it's just 1 over negative 1, which is negative 1. Yes, and negative 1 plus 7? Yes. And that's this point right here was 4 comma 8. And this point right there would be 2 comma 6. And do you get, we just need to find a few more points. Well, actually, on this test, we allow you to just have the asymptote and 1 point in each part of this. So I don't even need to find a whole bunch more points. If you can find the asymptote, which is the thing that makes it 0 on the bottom, then you just have to find 2 more nice clean points. One that's to the left of that asymptote and one that's to the right. So we found this one, which was to the right of it, and we found this one, which was to the left of it, and then the rest of it you can just kind of fill in. Because if you know that you have asymptotes, then let's say they're like here, and they're like here, and then you have a point here, and you have a point here, you're supposed to be able to go, oh yeah, it goes like this, and it goes like that. You see what I mean? I don't need a million points on this. Now this one would be a 1 over x that has been moved to the left and down. Let's say it went down 2, and let's say it went to the left 3 spots. Think about it. It's 1 over x, but it's been moved. What's the equation for that graph? This is a really important one. It got moved which way and which way? George, which way did it get moved? Down 2. Yes, and where does that go in my equation? On the inside or the outside? Outside. Yes, down 2 here, and then it also got moved what?
Left 3.
And how do I do that?
On the inside.
Classic mistake right there. It's not. That wouldn't be left 3. What should I do? There you go. There we go. That's the equation for that one. Because it got moved left 3. You know, that way 3. And it got moved down 2. The whole thing's down lower than it used to be. All right, I'm going to give you another one like that. Here's my asymptote. It got moved 2 to the right this time and up 8. Always start with 1 over x and then tweak it and go, okay, well, if this thing got moved up here, Mr. Young, right or left?
Right.
So, is that right too? Good, and then the rest of it? There you go. Okay, now there's only one other thing that they could do, and it really doesn't change much. And it seems like it should change a lot, but if I just put a 2 right here, That's a stretch factor, because like if I had put a stretch in front of it, it would end up being like 2 over 1, and the 2 would end up on the top. So if I make the top be 2, don't freak out like, oh, it's going to be completely different. Nope, it just gets stretched. And on this kind of graph, you almost can't see the stretch. I know that's weird, but like this gets a little bit more of a sharp turn, but you almost can't tell the difference. Like the green one might be stretched and the blue one isn't stretched. So don't think that that would completely change your answers. It doesn't. It doesn't change them much at all. It just stretches them a little bit. Okay. All right, so the last thing I want to practice with you is, I told you, if you can stick numbers in, let's say I even had that. You've never seen anything like that before. But you should be able to tell me what the graph looks like by telling me a few points on the graph. I said the most important point what to find is where the asymptote would be. What number could you stick in for x that would cause it to not exist and therefore there would be an asymptote there? Dominic? 0 is correct. So when you put in 0, you get 4 over 0. And that doesn't exist, so you say asymptote. Now I'm getting a little smarter, so I didn't put it at the top, because that way I can put one number on either side of it. Like one number bigger than 0 would be 1, and one number less would be -1. Everybody figure out what you get when you stick in -1 and 1. Tully, I'm putting -1 right here and here. Tell me what I get when I put a -1 in both of these two spots. Walk me through it. What does this become?
-2.
Plus 4?
2.
Divided by -1.
-2.
You are correct. Rissy, put in +1 and walk me through it. On the top, what do you get? 6 divided by 1, which is? There you go. And do you get, we've got the asymptote at x equals 0. That's the vertical, aka vertical asymptote, is at 0. See how I had to piece that together? This was x equals 0. Vertical asymptote, which is really vertical asymptote, is at 0. And then I got a couple points. -1, -2 is down here, and 1, 6 is up here. All right. Wouldn't it be nice to know where the horizontal asymptote was? Because, like, what if the horizontal asymptote is right here? Well, then it'd be easy to complete the graph. So that's the last thing I haven't taught you, is how to figure out where the horizontal asymptote is. But that's too much for one day. Like, your brain will explode if I try to do horizontal asymptotes today. Okay? But vertical asymptotes, you got to know those for today. Vertical asymptotes were the thing that made the bottom 0. Like, in this case, 0. When we stuck in a 0, it made the bottom 0, and that's the vertical asymptote, makes the bottom 0. So in this case, it was x equals 0. And that was this dotted line that goes right here. Horizontal asymptotes, I'll teach you that tomorrow. All right? Now, I've pretty much covered everything, but here is horizontal asymptote are the horizontal asymptotes, and vertical are the x equals. Please write those above them, just like I just did, to keep reinforcing which ones are which. It's so confusing. Horizontal and vertical. All right, next up, this one. Where did it get moved? Oh, gross. If I had just done this, I would have said it got moved left 3. Know what I mean? But the fact that we did this weird, like, added something on the top and the bottom? Well, this, if you want to learn how to do horizontal and vertical asymptotes, the vertical asymptote, I just said it 2 seconds ago, is what makes the bottom 0. So can you tell me again, what makes the bottom 0 in this case? Hello, what makes the bottom 0? -3, thank you. So that's the vertical asymptote. Now, I'm going to just, again, for right now, I'm not going to worry about the horizontal asymptotes. Maybe at the end of the hour I'll teach you that, but I don't think I have to. I think I can wait till tomorrow. All right, so if you were to sketch this with your computer, you'd type it into Desmos and it would give you this. That's weird. Did you ever have to graph one that hard? Nope. But tell me this. Would you think about factoring that? Would you have thought, oh, maybe I should factor it because, like the sign says, if you can factor it, you should? And you'd end up with x plus 1 and x plus 5 on the bottom. Oh my gosh, there's 2 things that make the bottom 0. So there's 2 vertical asymptotes. Look at that. So I did tell you the things that make the bottom 0 were a big deal, right? And I did tell you that the x should be a hint that it's called the zertical asymptote, as in vertical asymptote. So there's 2 vertical asymptotes on this one. You just had to work a little harder to find them. Okay, next up. These are called slant asymptotes because there's an asymptote running right there. We won't do those in this class because honors would do those. We don't do those. Okay, a hole in the graph is kind of a big deal. And I'm going to show you when that happens. Let's say you got this all factored and you got these answers. Did anybody notice that those 2 would cancel? That's what makes a hole. When x equaled -4, that's like the thing that would make that 0. That's where the hole would be. It's like it knocks out part of your equation, which then knocks out part of your graph. Part of your graph just goes, oh, I can't exist at x is -4. So holes can look like this. Your graph is going along happily, and then all of a sudden, oh, I can't exist at -4. That'd be like here. All of a sudden, there's an empty spot in the graph. And you just graph that by going, empty spot. It's like it punches a hole in the graph. It can't exist there. Why? Because when you put in -4, it not only makes the bottom 0, it cancels out the whole thing because there's a x plus 4 on the top and the bottom. So that makes what's called a hole. More slanty asymptotes, so don't even bother looking at that. We're not going to confuse you with that. But this one, you see how it's got a hole right there? That's what a hole in a graph looks like. And it happens when you got a x plus 3 over x plus 3 in your problem. That makes a hole at x is -3. See, that's what a hole looks like. All right. So now, that's right, I taught you the 1,000 trick. Do you guys remember that deal where you put in 1,000? And that told you, like, that tells you the horizontal asymptotes. Cool, I forgot that I had already taught you that. I just need to remind you about it now. So, we had this on a test already. The horizontal asymptotes, everybody write 1,000 trick right here. And that's where you're saying, where is this thing gonna go in the long run? Is it gonna have an asymptote, you know, like that's gonna make it stop up here? That's called a horizontal asymptote. Does it level off somewhere? And most of these problems do. Okay, so the horizontal asymptote, it goes y equals horizontal, horizontal. And if I put 1,000 here, and you have to know that 1,000 minus 1 is pretty much still 1,000. And this is 1,000, oh wait, we gotta factor that, because if you can factor it, you should. X plus 3 minus 1. I know you all can factor that kind. I'm just doing it a little faster than you maybe. 1,000 trick, 1,000 trick. And the top is pretty much 1,000. And the bottom is pretty much 1,000 times 1,000. Remember, these are a rough estimate. Would you agree that these 1,000s would cancel then? And you're left with 1 over 1,000. Is it really 1 over 1,000? Or is it just supposed to be 1 over an insanely big number? Isn't 1/1,000th pretty much nothing? If I said, let's share this pizza, and I'm going to give you 1/1,000th of it, I give you 0, really. Y equals 0. That's the 1,000 trick. We did it before. Now the vertical is what makes the bottom 0. I'm going to erase out these 1,000s. There's two things that make the bottom 0. X equals -3 makes one part of it 0. And x equals 1. Those are the things that make the bottom 0. Yes?
If it's a whole inverted asymptote, are we still supposed to put it in?
Excellent question. Okay, so now I'm really happy you noticed that. This has an x minus 1 on the top, and after I factor it, it's got an x minus 1 on the bottom, which means that's a whole. Now, which one is it though? Is it a whole or is it an asymptote? That's the question. Because you asked a very good question. Should it be an asymptote at x equals 1, or should it be a whole at x equals 1? And in the battle between the whole and the asymptote, okay, so the whole wins. It isn't an asymptote anymore because it's even more special. Anything that makes the bottom 0 has a chance to be that asymptote, but this one's more special than that because it canceled on the top. So there's a whole at x equals 1. All right, moving on to the next one. If you can factor it, you should. Everybody factor the top. Everybody factor the bottom. Probably something will cancel and make a whole. Whatever's left on the bottom will be vertical asymptotes, which are x equals things. Ryan Bontheus, top factors 2.
5 and 3.
You got it. Bottom factors 2.
5 and 5.
5 and -5. Good. Something cancels, Garrett. What cancels?
X plus y.
And that makes a whole at x equals, be careful,
-5.
-5 is correct. The thing that's left on the bottom is a vertical. And that's at x equals 5. And the horizontals, you have to do the 1,000 trick. These have canceled already. Now you can do the 1,000 trick. Here and here, do you agree that adding 3 to 1,000 doesn't really do anything? It's still 1,000. And subtracting 5 from 1,000 doesn't really do anything. It's about 1,000 over about 1,000, which pretty much cancels and becomes 0, or what's 1,000 over 1,000 equal to?
1.
1 is correct. The horizontal asymptote is at 1. Now I'm like, is it X or Y? Horizontal, horizontal. Okay, now, at the beginning of the hour, I really went into a ton of detail. I already covered like half of what's on your test. So if you feel like I just gave you way too big of a lesson, it really was. But the good thing is, now that I've talked about these things, you'll be a little better understanding of them as they come up for the rest of the unit. If I could only say that you had to have one skill, it would still go back to on the graphing part. You gotta know how to make points. If I stick a number into this equation, you gotta be able to figure out, if I stick in 2, what do I get for y? If I could only bless you with one thing, it would be, don't forget you can make an XY chart. So when you have to graph these things, yeah, you can find the asymptotes, that's the easy part. But finding a points on the graph is the hard part for most kids. And it's just sticking a number in and seeing what you get. All right, this is the part where you need to get to the homework. So everybody find the homework that is posted for today. It's a worksheet. I need to be able to quickly tell you which problems to skip because you know that I really try hard to keep it reasonably sized. Let me scroll up so I can see how long this thing is. No second page, just one? Okay, good. So then it looks like there's 6 questions. We're gonna just do the odds. Because I'm giving you so little time in class. Just do the odds today. Sean Nunez, read me number 1. It's an equation. I'll just write it down.
X plus 1 over X minus 2.
All right. And what does it want about that?
The horizontal asymptote.
Okay. Horizontal asymptote, vertical asymptote. Is that all it wants?
And the holes.
Oh, okay. If there's any holes. Is there any hole? Is there anything that cancels? Makes a hole? No. So then it's just horizontals and verticals. For the horizontals, you do the 1,000 trick. I really want to remind you what that is. That means if we go way to the right, if we say X is like 1,000, we go way over there, does it limit out and like have an asymptote that goes across the top there? And this one is about 1,000 over about 1,000, which simplifies to about 1. Then that means y equals 1 is the asymptote. Horizontals are horizontals. And why is it 1? Because it's 1,000 over 1,000, and that's 1. Okay, the verticals, that's what makes the bottom 0. Mr. Tivo, what would make the bottom 0?
2.
Yes, so that's the vertical asymptote. And there was no holes because nothing canceled. All right. All right, I think we can, I already said it though, I'm not gonna take it back. It's just the odds. If you feel like you didn't get enough practice though, you can go back and do another couple problems because I'm probably gonna make you do more tomorrow when we start class. You know what I mean? Like only do the odds tonight, but I'll probably say, okay, everybody go back and do the even problems at the beginning of the hour tomorrow. If you've already done them, you'll be happy. All right? Because these aren't that hard. And that's all I got for you for today.